Hi, I'm Paul from Easy Composites, and in this video I hope to give you a complete introduction to working with out-of-autoclave pre-preg carbon fibre, specifically the XPREG XC110 system, which can be used to produce both structural and cosmetic components. In this video we'll be producing this fairly complex engine cover. I'll briefly explain what pre-pregs are, how they're shipped and handled, and the equipment that you'd need to process them. And then I'll demonstrate in more detail the process of templating out, cutting the pre-preg, laminating the surface and then the backing plies, and then the correct way to vacuum bag the component. Finally, we'll oven cure the component under vacuum. In this video, I'll be using the mould that we made in a previous tutorial, so if you're interested in how we made this pre-preg mould, check that video out. I will also cover the alternative moulds that are appropriate for use with pre-preg processing. Simply put, pre-pregs are just conventional dry reinforcements like this carbon fibre that have been pre-impregnated with a resin that already has the hardener in. So here we have the plain dry reinforcement, and then here we have the pre-preg equivalent with the resin already impregnated into it. And because the resin is already combined with the reinforcement like this, to make parts using pre-pregs you only need to laminate the pre-preg material itself into the mould. So there's no handling wet resins like there would be in a hand laminating process or resin infusion process, and within reason it won't start to cure until it's heated. There are two main methods of processing pre-pregs. The most common is to use a heavy piece of industrial equipment known as an autoclave. This is essentially a pressurised oven. However, gaining in popularity with the advancement of pre-preg technology are out-of-autoclave pre-pregs. These are laminated and vacuum bagged in exactly the same way as an autoclave system, however, they only need an oven to cure. If you're working without an autoclave, so just in an oven, one of the biggest challenges you'll face is to reduce the surface pinholes and the void content. However, the XPREG XC110 system has been painstakingly developed to deliver results that are comparable to the results that you would get when processing with an autoclave. I've got a couple of examples here which clearly illustrate the difference between the XPREG XC110 and a conventional pre-preg. You'll notice that the 110 is void-free, whereas the conventional pre-preg here has surface imperfections all over. And this is typical of any attempt to process a conventional autoclave pre-preg in an oven. So these are the rolls straight from our freezer. If you've not worked with pre-preg before, you might be put off by being unsure about the storage, handling and shipping of the material, but actually it's all pretty straightforward. Essentially, when not in use, pre-preg should be kept frozen in a sealed bag. There's no special type of freezer. Anything from a small domestic freezer to a large walk-in cold store can be used. But for many individuals and small businesses, a chest freezer is ideal as it's easily big enough to accommodate a few rolls. In the case of this XC110 system, it has a working time or outlife of 4 weeks, which means that's the period of time it can spend out of the freezer before the resin system starts to deteriorate. So if you're planning to use the material within that period of time, you may never have to freeze it. If you were wondering what would happen if it was left out longer, we've got an example here, which you can see has gone really crispy. This has been out for around about 6 months, but it just shows that the resin's always curing even at room temperature. The rolls that we got out of the freezer earlier are still defrosting, and you can see the condensation forming on the surface. This is the reason why they must be kept in sealed packaging while defrosting. Otherwise, that condensation could form on the roll itself and potentially contaminate the material. So while these are defrosting, we're going to crack on and start out with the templating. We're doing this because we want to know the accurate shape of the various pieces of material that we're going to laminate into the mould. We're just going to use a very simple method of masking tape over the surface and mark the various joins and shapes that we have. There are many ways to create templates, from a trial and error approach using cut pieces of paper to CAD flattening methods. In all cases, the important part is choosing where to put the cut lines. The reason why I'm putting cuts down in the negative features in the corners is it actually makes the laminating procedure that much easier and reduces the chances of bridging, so you're less likely to get voids on the corner of your part. I can show you in more detail here. I've set up this small example which hopefully should illustrate how putting cuts in corners and negative features can really help in the laminating stage. So here we have it done in just one piece of material with an overly exaggerated bridge in the corner. But you'll notice it's very, very difficult to press the material down as it's got to pull it down from these faces to get the material in the corner. And if these were long expanses, it could be virtually impossible to press the material down into the corner. If we look to the other side, where we've done it in two pieces, so we have one piece that's been butted down into the corner, and then another one with a small overlap. It's now very easy to consolidate that material into the corner, as we only have to slide this small section against the other piece. And as I mentioned earlier, on larger sections, this is particularly important. I'm making these markings to show the angle that I want the fibre to line up to. That way, the final cut pieces will have the weave aligned. This masking tape guide can now be carefully removed from the mould, cut into sections and then applied to a backing. I'm using fluted signboard as it's inexpensive and easy to cut. The sections should then be flattened out as neatly as possible and extensions added for any overlaps required between the pieces. After cutting, mark the templates as required for identification and orientation. Now the pre-preg is fully defrosted, it can be removed from its sealed packaging. The templates can then be nested onto the material and marked out. One of the great advantages to working with pre-preg is how tightly and efficiently the material can be tessellated together, meaning that generally there is very little waste. When doing this, remember to pay attention to the fibre orientation and ensure that the components are aligned as needed. These strips cut at 45 degrees will be used around the rim of this component and will be cut to length on the job. You'll notice here that I'm using a knife for the cutting. Generally this is the quickest way, however, high quality shears will also cut the material very effectively. The backing ply can now be removed from its packaging and templated and cut in just the same way as we did with the surface ply. This is a heavier 450 GSM carbon, as opposed to the 210 GSM that we used in the surface ply. This builds the thickness more quickly and cost effectively than using the 210 gram throughout. Before moving on to the laminating, I want to take the opportunity to go through the compatibility of various mould materials with the XPREG system. So we have some that are highly suitable and recommended for the processing, and then we have some that aren't recommended but could be used, and then we have some materials that should be completely avoided. The mould that we're using in this video is the pre-preg mould that we made in a previous video in this series. It's got a maximum service temperature of 135 degrees C and is fully compatible with the XPREG. Another very common mould material is high temperature epoxy, which is hand laminated. So this is made using a wet gel coat, and then this has been backed up with a high temperature laminating paste. But equally, that could be done with a high temperature epoxy resin and glass fibre or carbon fibre. Then for short production runs or prototypes, you can work directly from epoxy model board. So this has been sealed with the S120 sealer, and this could be used directly as a mould. Other highly compatible tooling surfaces can be metals, so that could be aluminium, steel or stainless steel, which could be either folded into a mould tool like this or machined into a full mould. Or for producing flat plates, glass is absolutely ideal. This mould has been made using a standard epoxy tooling system, which means that it doesn't have a particularly high service temperature, so you'd be limited on the cure cycles that are available. So although it could be used, we don't recommend it. Another material which isn't ideal are vinyl ester tooling systems, such as our Unimold system. The reason for this is twofold. Firstly, again, it doesn't have a particularly high service temperature, so you're limited on your cure cycles, and you can encounter a compatibility issue between the mould surface and the pre-preg, leading to minor surface imperfections. There are some types of materials that absolutely can't be used with epoxy pre-pregs. So we have here a polyester mould tool, so that's a conventional fiberglass mould. This can't take the temperature and you're likely to get severe release issues. The other material we have here is polyurethane model board. This is widely known to cause cure inhibition with epoxy pre-pregs, so this also can't be used. So we're not going to have any of those problems today as we're using the epoxy pre-preg mould. Before laminating, easy release agent should be applied to the mould. Please refer to the product datasheet for application guidelines. Laminating with pre-preg is actually very easy. In fact, the hardest part is probably removing the backing plastic. A thorough and methodical approach is required to ensure that the material is laminated correctly. The aim is to ensure that the material is in intimate contact with the entire mould surface. To achieve this, you should systematically work the material down, starting from a centre point and working outward. Depending on the job in hand, there are a number of different laminating tools that can be used, ranging from rollers to the back of shears. On this job, I'm using a tool that I shaped from a piece of carbon fibre sheet. To maintain strength, the second piece of prepreg has been made to have an overlap with the first. Due to the geometry in this area of the mould, it would be difficult to laminate without creases, so I'm using some composite snips to cut the material and allow it to lap. 9 times out of 10, laminating faults are due to not properly pressing the material into negative corners and features in a mould. Although, as I discussed earlier, placing joins in these areas will help reduce the risk of bridging, you still need to pay these features extra attention. You will notice that some of the smaller details on the moulding I didn't template for. In this case, it's easier to cut the pieces by eye as they are needed. If you can remember, these strips for the rim of the part were cut at 45 degrees. Cutting them at this angle allows them to follow curves very easily, meaning that they only need to be cut and joined on the sharper bends. This 45-degree cut also helps the material drape more easily into the mould, making the laminating quicker and reduces the likelihood of creases, so snipping is not normally needed. With the first ply down, I'm now going to do a debulk. Now, on a component like this, it probably isn't necessary, but a debulk can help to reduce pinholes and reduce bridging in larger or more complex structures, and certainly on laminates with multiple plies, they're a necessity. Debulking is done using a perforated release film and then a conventional breather and vacuum bag. As with any vacuum bagging process, the bagging should be moved and positioned to ensure that it is properly following the form right into any corners. Using a blunt tool wrapped in breather can help to firmly press it into position. A full vacuum should be pulled on the part and held for at least 10 minutes to ensure all trapped air is evacuated. Once completed, the part can then be removed from the bag ready for the subsequent plies to be laminated. You can clearly see how well consolidated the laminate is after the process. We're now moving on to laminating the heavier 450 gram backing ply. As this material is much thicker than the 215 gram surface, it is slightly more difficult to laminate as it doesn't conform quite as easily. But in all other respects, the process is exactly a repeat of the surface ply laminating procedure, and so the same care should be taken to press the material into all of the sharp features and details. Although I'm not using one for this job, in certain circumstances a hairdryer or a low temperature heat gun can help soften the resin, which helps with drapeability. If used, this should be done sparingly so as not to overheat the material. With the laminating completed, we can now vacuum bag the part before curing. An unperforated release film should be applied to the laminate. It's actually just as important that this follows every detail and feature as it is with the prepreg itself. Allow for extra film by creasing it in the corners before firmly rubbing it down using a cloth. If needed, the film can be secured in place using flash release tape. As this is a small component, I'm going to put it into an envelope bag. In fact, it's very common to put multiple smaller parts into one large bag. For thin, intricate laminates like this, best results are achieved by using the breather only on the reverse of the mould. This provides the air path needed to the edge of the release film, but means that the film can get into all of the details without the breather getting in the way. As the vacuum is pulling down, the bagging film should be manoeuvred and manipulated so that it conforms to the laminate without having to stretch. You will normally need to disconnect the vacuum supply a few times to allow for repositioning before a full vacuum is pulled. Once you are happy that the bag is properly positioned, full vacuum should be applied and a seal checked for leaks. Once you think that you have the bag well down and perfectly sealed, it's recommended that a 10-minute drop test is conducted to ensure a perfect seal. With this component now vacuum bagged properly, all that's left to do is to cure the part. To get the incredible results that this prepreg system is capable of, it's absolutely essential that you follow exactly one of the XC110 cure cycles, which use a two-step cure to ensure optimal flow of the resin. There are some alternative cure cycles that can be used depending on your oven control and mould material, so please check the datasheet to find the cure cycle that best suits your needs. Because this mould is made using the XT135 tooling prepreg and our oven has full ramp and soak control, we'll be using the XC110's standard cure cycle. The standard cure cycle consists of two stages. Firstly, we control the heating rate to an initial lower temperature and hold it there for optimum resin flow. And as you can see from the graph, we then increase the temperature to fully cure the resin and realise the material's full mechanical properties. With the part now fully cured, we can remove all the vacuum bagging materials and demould it. The edges on a freshly demoulded part can be very sharp, so I'm just going to trim those to make them safe to handle. If you want further information on how we've trimmed and finished this component, take a look at our How to Cut Carbon Fibre video. So it's clear to see the excellent results that can be achieved using the XPREG XC110 system. We have a pinhole-free finish across the surface of the part, and there's no evidence of voiding or imperfections on these difficult 90-degree corners, which was no doubt helped by cutting and joining of the material in these areas, careful laminating and proper vacuum bagging technique. Although in this tutorial we've used the XC110 system to produce this relatively small engine cover component, the excellent mechanical properties of the Prepreg system allow it to be used to make fully structural components of any size. In fact, we have manufacturers using it to produce everything from bike frames through to airframes. I hope you've enjoyed this tutorial. We believe that the XPREG Prepregs offer an unrivaled combination of performance and value, and together with our complete range of vacuum bagging materials and equipment, it's never been easier to manufacture components using Prepreg technology. So, if you're interested in this material or you have any questions, please get in touch.
Click subscribe to stay up to date on our latest video tutorials. Search online for Easy Composites to buy these materials with fast worldwide shipping, or keep watching by following one of the video links on screen.